number 5.
It's 7u.
It's, if you think about it, it's cosine of negative 3u minus 4u, right? Because that's the cosine of a minus b. And a is negative 3u, b is 4u, but I'm subtracting them, so we get cosine of negative 7u. Just like tangent down here. A is negative 3x, b is also negative 3x. I look up here, I see that sign on the top. I know that this is tangent of a plus b. So we just could say tangent of negative 3x plus negative 3x. So we have tangent of negative 6x. Don't be careless with your signs. That would be destructive in this scenario, right? I know I'm adding the angles. I know they happen to be negative. Keep them negative and keep it addition. All right, let's look at number 1 just to kind of refresh our memory. I'm going to go ahead and convert that into degrees. That's negative 105. You do that by saying 7 times 180 divided by 12. That's negative 105. So we're going to say sine of negative 60 plus negative 45. I want to keep that addition there so that it keeps me from losing my negative signs in the mix. And we're going to say sine of negative 60. Then you're going to have cosine of negative 45. 30. Any multiple of 30. Cosine of negative 60. Sine of negative 45. Okay?
Wait, why are you doing the negative and the negative if you said that was one?
No, that's the one I would do. I would not do the one where you're subtracting and you have to keep in mind, because I might think that it's a negative, right?
Yeah.
But this is what I'm going to do with the angles. I'm going to go over here.
But wouldn't that be a subtraction in between them?
Nope.
You said you can see.
You can make it both ways. I just like to do it this way so that I don't get confused. That's me. This is a square root of 3, a 1, and a 2. That's negative. And here, bless you. Okay? I set it up like this. Sine of 60, right? I'm going to go look at the 60-degree angle. I'm going to come up here and try to find the sine of this angle. It's going to be opposite over hypotenuse. So we're going to get negative square root of 3 over 2. This is going to be the square root of 2 over 2 plus cosine of 60 is 1/2 times the sine of negative 45. That's negative square root of 2 over 2. So we're going to get negative square root of 6 minus the square root of 2 all over 4. Now if you had like negative square root of 6 plus negative square root of 2, that's the same thing. Let's look at tangent of 165, number 3. All right? What do you want to break that up into?
120 and 45?
So tangent of 120 plus 45. Remember with tangents here, we're trying to avoid 30, 150, 210, and 330. It's not wrong if I do that, but it's just going to make my problem a lot longer to deal with. Yes, ma'am?
Never mind. Let me just solve it. And then
So I'm going to write out the formula. This is a plus b, right? So it's going to be tangent of 120 plus tangent of 45 all over 1 minus tangent of 120 times tangent of 45. Now, 45 degrees is great with tangent. We know that the tangent of 45 is equal to 1. If I draw 120 out, we know that 120 goes over here. This leaves a 60-degree angle here. That means we have the square root of 3 right there, a 1 here, which is negative, and a 2. Let's plug everything in. The tangent of 120 is going to be negative root 3. It's the square root of 3 over negative 1, but we can just abbreviate that. Minus 1 divided by 1 minus that negative root 3 times 1. So the bottom part turns out to be negative square root of 3 minus 1 all over 1 plus the square root of 3. In a multiple choice setting, this answer is not going to show up, right? So we need to simplify it, right? This also isn't complete. Yes?
On number 1, how'd you get negative root 6 minus root 2 over 4? I got root 6.
Okay,
So,
Can I ask
if it's
a question?
here we go.
you just
Let me correct some typos here. Hold on.
move
That's plus 1.
how do you go
That's
to
plus
the
1.
order because it's-
Mr. Williamson, someone has a question over there.
Yes, ma'am.
So did you multiply the numerator and denominator by that
By which one? By these two?
same difference?
Right here?
Yes, to get the meaning.
I'm about to do that. Yes, it's okay. You are correct in your thinking. Let's go ahead and FOIL it all together. We're going to multiply the top two together. We're going to get negative root 3 plus 3 plus 1 minus root 3. On the bottom, when I FOIL it all together, I'm going to get 1 minus 3. So we'll end up with really just negative 2 on the bottom. You can FOIL it all out on the bottom. Your middle two terms cancel out. And root 3 times root 3 is going to give you that negative 3. Okay? I'm going to collect my like terms here. We're going to get 4 minus 2 square roots of 3 all over negative 2.
1 minus 2. Please don't put like
1 plus 3 is 4. And then negative root 3 minus root 3 is 2 of them, right? So minus 2 root 3. Yeah? So I'm going to cancel out, and I'm going to change the signs because that negative at the bottom. So we're going to end up with negative 2 plus the square root of 3. Make sure that you're using the right formulas. I gave you an additional formulas for half theta. Okay, does anybody have those formulas? It was not the ones on your formula sheet, because that one has a square root of cosine, 1 minus cosine over 1 plus cosine or something like that. And that's okay, but there's easier versions of it, right?
Oh, I know which one
It's-
you're talking about.
It's 1 minus cosine theta over sine theta, or sine theta over 1 plus cosine theta. So be careful. Those two formulas are by far much easier to work with than the radical with the 1 minus cosine and 1 plus cosine, okay? But you're welcome to use them. I mean, either one of them should get you the right answer. But in this example, we have tangent of theta equals negative 15 over 8. And I'm using theta, which is between 450 and 540. Where is that? How do I fix that? Those angles are beyond 360, right? So what I can do is I can just subtract 360 from these two angles to get them to be coterminal. What's 450 minus 360? 90. Okay. 540 minus 360 is 180, right? So really, this occurs in the second quadrant. I really don't care that it's too many circles around. I just care where the angle exists in the quadrants. So what I'm going to do, because I need tangent of theta over 2, I need the sine and the cosine of the situation. Well, I don't have it. I only have the tangent, right? So I'm going to draw that triangle right here. I know that it's the opposite over the adjacent. So I'm going to take those values. So 15 would go here, 8 would go there. This is going to become a negative 8 because it's in the second quadrant, right? X's are negative here, Y's are positive. 15, or 8, 15. If I use the Pythagorean theorem, I'm going to find out 15 squared plus negative 8 squared, and I square root that number, I'm going to get 17 as the hypotenuse. This is important because when I go to write this out, I need the sine of this angle here. And so the sine is going to be 15 over 17. I also need the cosine of this angle, which is negative 8 over 17. Once I have those two numbers, the only thing I have to do is pick one of these. I tend to like the first one. I like to have a single denominator on. I have to work with all that other stuff, but it's up to you. It doesn't really matter. I'm going to have 1 minus the cosine, which is going to be negative 8 over 17, divided by the 15 over 17. Once we've plugged into these formulas, and for half-angled formulas, pretty much all of them, the majority of the work that I'm doing happens in just simplifying. In fact, it's not trig, it's just algebra, right? And so I'm going to get a common denominator for that first part. So it's easy. I'm just going to take the denominator and write it on top of itself like that. Minus a negative always indicates we're adding. And then we're going to have 8 over 17. And that's all over 15 over 17. I didn't even touch the bottom. At that point, I'm allowed to kind of add the numbers together, give a fraction on the top. So this is going to give me 25 over 17, all that over 15 over 17. What do you do next?
Multiply by the reciprocal.
So we're going to take this up. We're going to multiply the 17 over the 15. That cancels out. And we're left with 25 over 15.
That reduces to 5 over 3. Yes, sir.
And that would be how you would solve that one.
Beautiful. Mr. Blake, how much do you think a mathematician makes in a year?
Look at 14. And so now we're involved with the double angle identity. I cannot stress to you enough, take a second and look at what I've asked you to do. I can remember several years in the past where people would simply just pick the formula they wanted to use. Didn't matter what I asked about. They just kind of picked one off the formula sheet. I'm going to ask you for something, right? Tangent of 2 theta, and I'll provide all these formulas for you. I'm going to put them right over there on the board. Okay? Half of them are there. I'll put the other half later on. What is the tangent of 2 theta? I always forget about this one. Is it 2 tangent squared? What?
It's 2 tangent over 1 minus tangent squared.
1 minus tangent squared?
Yeah.
Yeah, I always forget about that one. I just don't ever use it.
What do you think?
Okay, so at this point, double angle identities. I have the cosine. They tell me that it's in the first quadrant. I need the tangent of this formula, but I don't have it, right? I only have the cosine. But the good news is that it's in the first quadrant, so it's really easy for me to draw. We know that we have the adjacent and the hypotenuse because that's what cosine is. So theta always occurs at the origin.
It's a 3, 4, 5 triangle.
And so it is a 3, 4, 5. 25 minus 9 is equal to 16, and the square root of 16 is 4. So the Pythagorean theorem always gets you that third side. Make sure you do it the right way. Make sure that the sides, the legs of your right triangles, are never longer than the hypotenuse. Sometimes we kind of just go too fast and we just add or subtract incorrectly. That's a good double check. Always make sure my legs are shorter than my hypotenuse. Okay. At this point, we know the tangent of the angle is 4 over 3, the opposites over the adjacents. And then I'm just going to plug it all in. Everybody want to watch? Everybody look on the screen. There's a common mistake that people make every single year. And if you do this, for some reason, it just, you make this mistake and you start plugging stuff in, and then all of a sudden things get all weird on you and you just lose it. You don't know what to do because it's not working out right. So here's what a lot of people do. They say 2 times tangent of 4/3 over 1 minus tangent of 4/3 squared. And that's what they think is the correct answer. What happened? What did I do?
You didn't take out the tangent.
I treated the tangent of theta as if it were just plain theta. Correct me if I'm wrong, but 4/3 is not an angle measure, right? Not even close. So don't do this. When you replace that, like this is big time wrong, but I see it enough that it strikes my memory as common, right? That's a big issue. And if that's pervasive, tomorrow's gonna be a bad day. Okay? Because that'll kill your grade. Because that's in every problem, right? We don't want to do that. So keep in mind that problem. If you get confused and just, what am I doing wrong? If you're doing that, I will tell you you're doing that, right? So don't be afraid to ask the question, okay? So let's do it the right way. 2 times something on the top, then 1 minus that same something squared. Sometimes I write it this way to kind of give myself some blanks to fill in. It's easier to see. Well, that's something that I left out was the tangent of theta. Well, that's easy. That's right here. So 4/3 over 4/3 here. And then we're just going to say, well, remember, this is 2 over 1. Tops multiply, bottoms multiply. 4 times 2 is 8 over 3. On the bottom, we're going to have to do a little bit of addition or subtraction. This is going to be 16 over 9.
So you do 9 over 9.
Correct. 9 over 9 minus 16 over 9. On the bottom, that's going to give me a negative 7 over 9. We're going to take that denominator, right? So we end up getting 8/3 over negative 7/9. On your way. Okay. And so we're going to take that and we're going to get the reciprocal. And we're going to multiply by 9 over negative 7.
You get negative 70, you get
3 goes into 3 once. 3 goes into 9 3 times. So we're going to get 24, or negative 24 over 7. Or you could get 72 over 21, negative 21, and then reduce that, however you want to do it. Does that make sense? Okay, we are going to work on number 12. The formula for sine of half theta, or theta over 2, is plus or minus the square roots of 1 minus the cosine theta over 2. Things you should pay attention to. Plugging this stuff in, getting the fractions kind of started, not a big deal. Like, it's mostly straightforward. Simplifying this, especially with the radical involved, if it's a multiple choice question, they're going to rationalize it. My bet is if your answer wasn't just like what I just showed you, is you got it right, probably, you just didn't rationalize it in the end. I'll walk you through that. Okay, first of all, let's draw our angle. We know that it's in the 4th quadrant because it's between 270 and 360. Right, here's 270 and 360 would be back here. And so we know that it looks like this. It's the opposite over the adjacents. We know that this is going to be a 12, and this is a 5. In the 4th quadrant, the y value is always negative, right? The x value is always positive. That's why we get the negative 12. 5, 12, 13 is my common right triangle. If I don't know that, 144 plus 25 is 169. I can take the square root of that. It's going to give me my 13. I need to know the cosine, right? The cosine of this angle is equal to 5 over 13. It's positive, right? 4th quadrant, cosine's always positive. So I'm going to plug this in. Well, this is a problem. I need to know, I'm asked to find the sine of this angle. I need to know where theta over 2 is, what quadrant it's in. It's really simple to find that. I know where theta is, so what I'm going to do, I'm going to take that 270 theta, which is less than 360, right? I don't want to know about theta, but I do want to know about theta over 2. So I'm going to take that inequality. It's just like an equation. Whatever you do to one part, you do to all 3 parts, and it's still true. I would like to know this. Well, if I'm dividing the middle by 2, I'm going to divide the other 2 sides by 2. This will tell me where my half of that angle will occur. And so this is going to be 135 is less than or equal to theta over 2, which is less than 180. So which quadrant is this? Where's 135 to 180? Second quadrant, right? So it's asking me to find the sine and the angle's in the second quadrant. Is sine positive or negative in the second quadrant?
Negative.
All students positive. Right? So you're looking at it like this. All students take classes. That's where I am. That's what I want to do with it. So that means it's going to be a positive number. So that means up front, I'm going to be choosing the positive sign. Or I'm going to forget about this altogether, and I get lucky because it's positive. If it's negative, that's when I'm going to have a problem. If that's free response, minor deduction there. But if it's multiple choice, you need to check it. Because if it's multiple choice, you miss the whole question. Because you'll choose the wrong multiple choice answer. Okay? Here we go. 1 minus the cosine, that was easy, it was 5/13. All that over 2. So I'm going to go ahead and I'm going to get 13 over 13 minus 5 over 13 over 2. Are there any questions on... I keep doing that over and over again. I just assume you understand what I'm doing. Does anybody have an issue with that step?
How are you getting the 13?
1 is the easiest thing to find a common denominator with. Because a 1, the value 1, is always the same thing over the same thing. So if I know what the denominator needs to be, and I do, it's 13, I just do that on top and bottom. Every single time. Last time it was like a 17 over 17 or 24 over 24, whatever it happens to be. There's no thought in that. Straight through it, piece of cake, run it through it. All right, 13 minus 5, it's going to be 8 over 13, all over 2. Right, still under the square root. That's a 2 over 1. I always write that down. Because a lot of the time we think, oh, that's in the bottom, so when I flip it over, it's 1/2. Or it's 2, or whatever you want to think about it. I'm going to flip that up. It's going to be 1 over 2. This cancels out and gives me a 4. So we're going to get 4 over 13. And I could leave it like that. However, I can split it like this. If I have multiple choice questions, it's going to rationalize this event. We can take the square root of 4. That's nice. That's going to be 2. But I'm also going to rationalize by multiplying by the top and the bottom by whatever the radical is on the bottom. So that's going to give me a 2 root 13 over 13.
But we can leave it as square root of 4 over there.
If it's free response, I'm okay with this answer. But if it's multiple choice, that won't be an answer choice. So can I do it? I would be prepared for that. The only thing you have to do is split. It's not that complicated once you think about it. I'm going to get a radical with a fraction in it. I'm going to split that radical into the top and the bottom. And then I'm going to multiply top and bottom by whatever the radical is on the bottom. That's rationalization. And at that point, whatever needs to be simplified should be simplified. Or not, if it can't be. Sometimes you multiply like this one. I could take the square root of 4, but that's really all that I could simplify. Square root of 13 times the square root of 13 technically is the square root of 169, but that's just 13. So that's why it becomes 13 on the bottom. You can't multiply a radical times a whole number. It's just 2 times the square root of 13. That's why we leave it alone.
Oh wait, that's how.
Here-
I'm asking about the bonus first.
Here we look at number 13. This one is asking us to do sine of 2 theta. The good news about that one is that 2 sine theta cosine theta is the formula I'm going to need. So I'm going to be drawing this in the first quadrant. The opposites over the adjacent, right? So this is going to be 4 and 3. Of course, this is a 3, 4, 5 right triangle. This is easy enough. It's going to be 2 times the sine, which is going to be 4/5, times the cosine, which is 3/5. And then I'm just going to multiply it out, right? 2 times 4 times 3, which is 24, over 5 times 5, which is 25. Remember that 2 is over 1. With fractions, you multiply the tops together, bottoms put together, and leave it alone. Or simplify if you can, but in this case, that's it. Which one would you like to try? Yes, that's true. Let's try number 17. Okay, so I'm gonna pick, I guess it doesn't even really matter. I'm gonna pick the left side, right? Let's try getting this side to look like the right side. Rule is, you can use any trig function you want, but you can only touch one side of the equation.
Make a cosine.
So the first two things is going to be sine of 2x, instantly realizing that this is the cosine of 2x. I know that's good idea because guess what I see on the other side? Sine of 2x. So that's a good thing, right? Then minus, I see all of this here, right? I'm really thinking I'm going to change that into 1 minus 2 sine squared x. Because that really reminded me of that side. And so now I'm going to kind of let that just distribute the negative sign and collect all my like terms. So we're going to say sine of 2x minus 1 plus 2 sine squared x. I'm just going to rearrange it to make it look like the other side. So we have 2 sine squared x minus 1 plus 2, not 2. Minus, what is it? Sine of 2x.
Is that 2 supposed to be like square root like over it? Or?
This is not squared.
It was not me this time. I know y'all know it.
It's sine of 2x. Here on page 4, we are solving equations again. Okay, let's try number 22. We have cosine theta equals, well, which double angle identity should we swap out?
The one with the cosine.
Correct. 2 cosine squared theta minus 1. We chose that because I already had a cosine. And I'd really like to keep everything in terms of just one trig function. Okay? So we're going to kind of bring that together. We're going to say, I'm going to bring it over to this side. So we're going to have 0 equals 2 cosine squared theta minus cosine theta minus 1. Goal here is to keep that squared term positive. It's going to make my factorization easier. Here we have 3 terms. So can't do GCF because 1 doesn't share anything in common with the rest of them. But I can definitely factor it, or unfoil as you say. Right? It's 2 cosine theta times cosine theta will give me that one. And then 1 is nice because it's just 1 times 1. Now I just have to work out the signs.
It's plus 1 and then minus 1.
It would be plus 1 and then minus 1. I want to do the outer, right? So we have to do the outer terms and the inner terms and subtract them or add them. So it's 2 cosine theta. Actually, it's negative 2 cosine theta. And then it's going to be plus 1 cosine theta. If I do that, I'm going to get negative 1 cosine theta. But that's what I should get. I check that middle term. I want to make sure the number and the sign out front match. If they do, I did a good job. I'm going to keep going. If it's wrong, I only had 2 options here, right? So I'd switch the signs. I can double check it to make sure, right? Really what we're doing is we're foiling this back together to make sure that we got it right. We knew the first ones and the last ones were good, but the middle parts, the signs, we weren't sure about. So we're going to set them equal to 0. 0 equals 2 cosine theta plus 1. And then 0 equals cosine theta minus 1. At this point, solving each one. So we're going to add 1 and divide by 2. Subtract 1 and divide by 2. So we have negative 1 half equals cosine theta. And then here we have 1 equals cosine theta. I'm going back to my unit circle, my left-hand rule, my right triangle, whatever your method is at this point, you should be kind of focused in on a specific method that you kind of go to all the time. There's a million ways we can do this, right? And so cosine is negative. I'll use the triangle method in the second and fourth quadrants. I know that you get a 1/2. This becomes square root of 3. That's negative. This would be negative square root of 3 here and a 2 there. So what angle gives you a cosine of 1/2? That's your 60, right? So that ends up being 120 degrees. What's the one in the fourth quadrant?
200, the fourth or the third?
Oh, sorry, third quadrant.
240.
240 degrees. Okay? Cosine equals to 1. Remember, x is equal to 1 only in one place in the unit circle. What angle does this become? Theta equals 0 degrees. So this one has 3 separate solutions. Don't forget that I can always use my calculator to get myself started. If I did this one, I would have gotten 2/3 of the answer.